Let's have a look at this one then. R cos squared theta equals 1. Right, okay, so let's rearrange this first of all then. So moving the cosine squared from times down to divide is 1 over cosine squared theta. And we can write that as cosine theta to the power, just to be clear, minus 2. So we can put that in the calculator. If we put in theta as 0, first of all, cos 0 is 1, so 1 squared is 1. So the value is 1. So there's our first value at 0 then, which we can mark down here. Okay, so let's put 1 in here, just by, say, there. So that's the value of 1. Now pi over 6, let's put that in our calculator and see what we get. So I've done 0 over 6, which is the 0. Now we need 1 over 6. Cos to the power is 4/3. So we go up here and that's 4/3, which is 1 and a bit. A little bit back from there. Now pi over 4. So that's 1 over 4 now. See what we get there? We get 2. So it's shooting out, isn't it? And then, what do we get now? Let's go around again. And we'll do, this was 2, wasn't it? Pi over 4. Now pi over 3. So we got 1 over 3 now. See what we get there? We get 4. So this is shot up now. So it's difficult to draw on the sketch. So basically it came round from here, goes up here and goes up there. And it'll shoot off to infinity, won't it? Like so, here. Because cos is 0 and 1 over 0. So this is simply going to shoot up to infinity there. So it's almost a vertical line. So maybe I should draw a little bit more noticeably steep, because that was only 1.4, wasn't it? And this was 2, and this was 4, and this will be infinity. So we're going to go around and we're going to come in, but then we're going to kick back because it shoots up to infinity. Okay, that's round to 0 to pi over 2. Now we need 2 pi over 3. So let's do that one. See what we get there. We get 4 again, because it's a squared, isn't it? So the values will be the same, really. So that will be a 4 up here somewhere. And then let's confirm it. 3 pi over 4, next one. Got a feeling that's going to be 2 again. So let's just put it in, just to verify that. 3 divided by 4. 2, yeah. So that would be 2. Very, very similar. And then 5 over 6, let's just put that one in. 5 over 6, we should get 1.4. It's a good way to double check anyway. 5 divided by 6, 4/3, which is what we had over here. 4/3, which will be here, say. And then we had cos pi. When pi is 1, cos pi is -1 squared is 1, 1 over 1 is 1. So that's the value of 1. So again, we got the same, there's symmetry here. And it comes down and like that. And then, of course, we know that it's the same the other side, isn't it? Because it's the cosine function. So we're going to get it to come back on itself, sort of thing. Little cusp here, really. And then it shoots off to infinity like so. So let's try and draw it a bit more correctly then as a sketch. So a bit thicker pen. It's going to shoot off to infinity and then come around like so. Oh, I've not done that right. So I'll do this one first. Shoot off to infinity and kick back like so. And then it's going to do the same on this side. It's going to curve around and kick back. And the same goes this side. So I'll try and draw some symmetry here if I can. Like so. And then like so. So something like that, isn't it? And these lines shoot up to infinity as they go up. So again, not too great a sketch there as they shoot up. Okay, so let's have a look at the sketch then. So we want 1 over cos squared, or cos theta to the -2. Let's go to our plotter then, here, and we want cos r, and it's cos theta to the -2, isn't it? Cos theta. Put a bracket around it all just to be absolutely safe. Power -2. Put another bracket just to be on the safe side there. See what we get on the. Yeah, that's interpreted it correctly, and as we saw, it shoots up a little bit less exaggerated than the sketch I've done here. Here's the sketch here. It shoots off to infinity and infinity, doesn't it? So it comes around eventually, but it shoots off to infinity quite markedly. Okay, good.